Greetings, this is Aniruddh Tomar, and I will give the presentation for the paper titled Earthen Construction in Countryside Techniques, Materials, and Stereotypes. The authors of this paper are Mohd and Sohaib, Aniruddh Tomar, and Hiba. Let's start with the introduction. In the 21st century, planet Earth is facing the crisis of overpopulation. With this crisis comes the crisis of the shortage of dwelling units. According to the data of World Bank, there will be a requirement of about 300 million dwelling units by the year 2030. This is a vital issue for developing countries as it needs a strong economy and resources to meet such requirements. 54% of Earth's population live in the urban areas, which makes about 46% of the population living in the rural areas. For countries like India, 67% of the population live in the rural areas. This calls for a sheer need for construction for housing in rural areas. However, housing and infrastructure construction also require a huge long-term investment. This need for housing in India can be met by earthen construction, material and techniques in the rural areas. Earthen construction involved the use of urban materials and techniques like adobe, cob, mud, etc. for construction. However, for this paper, earthen construction is limited to only single story. For multi-storied earthen construction is beyond the scope of this paper. Throughout the life of a building, it has a direct impact on our environment. Therefore, there is a need for choosing materials and construction techniques that contribute to the sustainability of Earth. Earthen materials and techniques has proven to be sustainable, efficient, economic, and labor unintensive. So let's move to the next slide. Materials and techniques. Let's start with Adobe. Adobe is commonly used as building material in many parts of the world. Generally, Adobe sun-dried bricks made up of 20% clay, coarse sand, fine sand, and water, silt and water. Sorry. Organic materials such as straw are also added. It can be stabilized by adding cement or lime. Adobe is usually excavated on site, aiding to low embodied energy, no transportation cost, and low carbon footprint. Fireproof, inexpensive, and long-lasting structures can be made with this material. Another advantage of Adobe is its sound insulation properties. Table 1 describes the thermal conductivity for different sources. Let's move to the next slide. Mud. Mud is the most abundant and flexible material found in our environment. The malleable property of mud makes it easy to use. It offers good insulation as compared to RCC structures, and also costs less as it is locally excavated on site. Easy and economical maintenance of this material makes the mud structure long-lasting and durable. The building center, Delhi, has developed a technology to give the exterior facing of mud blocks a veneer of stone, cement, or tile. This prevents mud blocks from the water and also adds to the aesthetics. Many technical developments are observed in the field of mud architecture. Stabilized mud blocks (SMB) are made by adding cement or mud, cement to mud, specifically 7% of cement or lime, which is also less vulnerable to termites and rodents. The Center for Application of Science and Technology to Rural Areas, ASTR, developed stabilized mud blocks with 5% cement and can withstand a pressure of 45 kgs per square centimeter. Let's move to the next slide. Cob. Cob is an earth building technique in which a mixture of sand, clay, straw, and water is kneaded and lumps are formed, which are further compressed and sculpted by hands to form foundation and walls. Materials are locally available and economical. Carbon footprint during the processing of these materials is low, and carbon dioxide emissions from transport can also be reduced. Cork structures have a good thermal mass which helps in internal temperature fluctuations during warm days and cold nights. Mixture of materials is quite malleable, which makes it easier to make a curved structure, which adds to the sustainability of the structure. Let's move to the next slide. Compressed earth block. These earth blocks are made by compressing earth slash soil in a manual or mechanical press. Compressed earth blocks or CEB are available in various sizes, including the traditional brick sizes 230 mm by 115 mm by 75 mm. Easily accessible earth for CEB results in low carbon emission and low embodied energy. CEB has a good thermal performance and also enables good humidity control, especially if exposed. The stabilized CEB is a better choice for load-bearing structures in rural areas. Let's move to the next slide. Rammed earth. Rammed earth is a construction technique in which moist earth is mixed with clay, gravel, and sand, is rammed into a rigid framework in layers until desired height or width is achieved. Great Wall of China is a great example of rammed earth construction. Advantages of using rammed earth are low carbon footprint and embodied energy as locally available on-site material is used. In a project in India, the structure created with soil stabilized with cement can lead to a 62% reduction in embodied energy when compared to a typical RCC structure. Table 2 gives a comparison between the total production energy per unit length of wall made of cement to stabilized rammed earth and steel frame. Let's move to the next slide. Mud fusca. Mud fusca is a traditional insulating technique for flat roofs in which a thermal mass of mud is used to insulate the roof. The roof is prepared by cleaning the surface and spreading hot bitumen at 1.7 kgs per square meter. Coarse sand layer at 0.6 meter cube of sand over 100 square meters is spread over while bitumen is still hot. Another 10 centimeter thick layer of puddled mud is mixed with bhusa, which gives a proper slope of 1:40. An additional layer of mud is applied and is left to mature for 7 days. Finally, a coat of cow dung is applied to fill any cracks in the mud plaster. Towards the end of paving, towards the end, tile paving is done. It is a low-cost, thermally efficient technique for insulation of roofs and also needs low embodied energy. The next one is filler slab. In any slab, the upper part of the slab is under compression while the lower part is under tension. Concrete can resist compression fairly well and is weak against the tension. In an RCC slab, concrete is much less feasible in the lower part of the slab, so it can be replaced with low-cost, lightweight material like manmade tiles. Filler slab reduce the overall weight of the slab transmitted on the load-bearing walls, columns, thus reducing the amount of reinforcement and ultimately reducing the cost of the overall structure. Table 3 gives you the energy and cost comparison of different roofing options. Let's move to the next slide. Wattle and Dobe. Wattle and Dobe is a traditional walling technique. In this technique, wooden or bamboo sticks are tightly woven together, known as wattle, and coated with a layer of clay-rich mixture of straw, soil, hair, or cow dung known as dobe. Wattle and Dobe use less material and time as compared to adobe and curved structures. Locally available materials uses low embodied energy and reduces carbon emission during the processing. This technique can be used with other urban construction like adobe or cork to get a better thermal mass. Wattle and daub walls are durable and long-lasting and are easy to maintain. Let's go to the next slide. Sandbag. Lightweight plastic bags are filled with earthen mixes or sand makes up for the sandbag construction. In this construction, a frame structure, column and beam is utilized where the sandbag earth act as a fill-in by laying a course within the pillars on the foundation wall. For buildings without beams and pillars, a curved wall of sandbag should be constructed for added strength. A chicken wire is then attached to the wall, which will allow the plastering. This material, as well as the technique, has a relatively low carbon footprint and can be recycled and reused. Minimal water is required in construction of such buildings. Good thermal insulation aids in regulating the internal temperature. These also provide an excellent sound insulation. Let's move to the next slide. Inverted urban pots. A cost-effective and easy method to minimize solar gain is by covering the flat roof with inverted earthen pots. In this process, inverted earthen pots are laid supporting each other. The space within is filled with lime or cement mortar, which is then finished with the terracing material. These pots are made of recyclable and locally available material, hence they boost the local employment. This also leads to low embodied energy. Due to gaps in the pots, they increase the insulating capability of the roofs, which leads to thermal as well as sound insulation. Let's move to the next slide. Cavity wall. Cavity walls consist of an external lime, mud, cement, brick, and a consistent hollow space and an inner block leaf as same as or might be a little bit different from the external leaf. Since the hollow space between the leaves or the layers consists of air, heat transmission from outside to inner part of the building is hindered, thus maintaining an optimum temperature, that is the thermal insulation in the interior. They are more economically feasible as compared to their solid counterpart on the front of thermal insulation. A 275 mm cavity wall will cost much less than a 328 mm brick wall. The hollow space prevent the outer moisture to seep inside the wall, hence preventing dampness and efflorescence. These walls provide good sound insulation. They are much lighter due to their hollow construction anatomy, thus decreasing the load on the foundation. Let's go to the next slide. Brick jali walls and lattice brick walls. Jali walls allow free flow of natural air, aiding to achieve comfortable temperature in the interiors. It also allows natural light and creates intricate patterns of shadows. Lattice brick walls allows utilizing the air pressure to draw cool air from an adjacent pond. It also adds to the aesthetics of the structure and needs much less maintenance as compared to the solid wall. Exemplary use of jali walls and bricks can be observed in low-cost housing by Laurie Baker. Let's move to the next slide. Modernization and sustainability in a traditional clay brick production. This part has been divided into three parts. Number one, energy efficient brick technology. In rural areas of India, batch-fired plant mills are most common. These are not energy efficient, labor in, and are labor intensive and have high carbon emissions. Only a small amount of heat is utilized in the drying and firing of non-uniform bricks, while most of the heat is wasted in the atmosphere. Vertical shaft. Number two, vertical shaft brick kiln. It consists of a rectangle shaft which act as a chimney. The green bricks then are loaded in at the top and then travel to the firing zone in the center. In this process, the phenomenon of movement of hot air moving upward and the green bricks moving in the opposite direction, that is downward, hence cutting down the fuel use and high thermal efficiency. It saves up to 50% of the fuel as compared to your normal brick kiln. The bricks produced have low breakage percentage and the kiln has obviously reduced population. And the third part is, which is one of the most important phenomenon or technique is alternate fuel for brick firing. Conventional fuels are replaced by alternative fuels by up to 50% of current quantity. Spectrum of alternative fuels ranges from industrial waste, for example, from sponge industry to agro bio-waste like husks from coffee and rice, sawdust, dry stalks, and coconut shells. One of the alternative fuel is biobricks, which can be produced by compressing up to 30% of biomass with locally available conventional fuel like coal. Nowadays, finer fuels such as husks, sawdust are added to clay mix, which leads to complete burning of fuel within the mix, hence reducing the chance of cracking. Conventional fuels can also be charged. Let's move to the next slide. Vernacular building system analysis during earthquake, behavior and improvements. Let's talk about rammed earth. Behavior. The walls separate along the joints. There are there can be wide angle cracks seen in the walls, and walls collapse completely most of the time at the times of earthquake. The improvements which can be added here are crush joints with L-shaped wings of the house. Joist should extend in the wall rather than using stone loadings or support floor joists. Number third, limit construction to one story. Use of cement mortar, use of strong wood lintels, bamboo reinforcing within the walls, knee braces installation, wall thickness decrement, and tapered walls. Let's talk about mud behavior during an earthquake. Diagonal flats formed on the walls, cracks along mortar joints, or separation along the joints. Failures of wall, hence anchorage and bearing of roof is destroyed, leading to its collapse. Now the improvements. Timber posts embedded in walls to support the roof. Use of angle brace, compressed or fired brick with cement mortar and collar at corners, and use of lightweight roofs. Let's go to the next slide. Let's talk about the stereotypes. In most of the developed and developing countries, children are brought up believing that organic materials are temporary. It is believed that mud or bamboo houses are temporary and cement houses are permanent, but in reality, this argument is gravely flawed. Since during the ancient times, materials like mud and lime mortars have been used for construction of architectural marvels, which have withheld the test of time and are still standing. For example, Pyramid of Giza and many structures like Taj Mahal and most of the structure of Mughal architecture and Egyptian architecture used lime mortar and mud. These material, when used methodically, strengthened over time. It is possible to construct a structure using mud and organic material, which are compliant with contemporary needs, moreover, can withstand disasters. These materials should be viewed as an intentional choice and not as uh, an economical drawback. Children shouldn't be taught that mud houses are kacha, that is temporary, and cement or RCC houses are pakka, that is permanent. Conclusion. The choice of materials and techniques for the construction of a building has direct impact on our environment. Earthen materials and techniques allow energy efficient, eco-friendly, and economical and sustainable development. They have less environmental impact as most of the earthen materials are excavated on site and they are locally available, thus reduces embodied energy and cost of transportation, leading to low carbon emission throughout the construction. They aid to thermal comfort by passive solar heating and cooling. Earthen structure with proper earthquake resistant construction techniques also withstand seismic activities due to their high strength. Earthen construction are durable, long lasting, and need low maintenance. Maintaining a balance between modern and conventional structures or building techniques is also necessary as both together contribute to excellent results. For example, in case of compressed stabilized earth block and stabilized mud blocks. These are the references. This paper was guided and supervised by Dr. Sharmin Khan from Department of Architecture, Aligarh Muslim University. Thank you.